Hi, this is Srikanth, Assistant Professor of Triple Department. In this session, I'm going to discuss the H parameter model for common base amplifier circuit. The common base amplifier is the another type of BJT configuration where the base terminal of transistor is common terminal to both input and output terminals. Hence, it is known as common base. In the common base configuration is less common as compared with the common emitter or common collector configurations, but still used due to its unique input and output characteristics. For the common base configuration to operate as an amplifier, the input signal is applied to the emitter terminal and the output is taken from the collector terminal. Thus, the emitter current is also the input current and the collector current is also the output current. So, here the base terminal is common. So, emitter current will be acting like a input current and collector current will be acting like a output current. But as the transistor is a 3-layer 2 PN junction device, it must be correctly biased for it to work as a common base amplifier. That is, base to emitter junction is forward biased. Here the common base amplifier circuit using NPN transistor. The base to emitter junction is forward bias. Base to emitter junction is forward bias. That's why positive is connected to P and negative is connected to N. And collector to base junction should be reverse bias in order to make the transistor configuration in active mode. That's why positive is connected to N type and negative is connected to P type. Base to collector junction is reverse bias and emitter to base junction is forward bias. And here the collector is taken as the output and emitter is taken as the input terminals. Then we can see from the basic common base configuration that the input variables relate to emitter current and the base to emitter voltage, and the output variables relate to collector current and collector to base voltage. Since the emitter current is also input current, any changes to the input current will create a corresponding change in the collector current IC. For a common base configuration, current gain is given as I output by I input, which itself is determined by the formula IC by IE. The current gain for the common base configuration is called alpha. Here in a BJT amplifier, the emitter current is always greater than the collector current, as IE is equals to IB plus IC. The current gain of the amplifier that must be therefore less than 1, where IC is always less than the IE by the value of IB. Thus, the CB amplifier attenuates the current with typical values of alpha ranging between 0.98 to 0.995. The electrical relationship between the three transistor currents can be shown to give the expressions for alpha, beta and gamma. Here IE is equals to IB plus IC, and where alpha is equals to IC by IE and beta is equals to IC by IB, where IC is equals to alpha into IE, which is equals to beta into IB. Thus, from this we can take alpha is equals to, we'll get it as beta by 1 plus beta, and where beta is equals to alpha by 1 minus alpha. The amplifier current gain is AI is equals to output current by input current, that is equals to beta by beta plus 1, which is approximately 1. Therefore, the beta value of standard bipolar junction transistor is 100. Then the value of alpha would be given as 100 by 101, that is approximately 0.99, which is equals to 1. And amplifier voltage gain, here voltage gain is nothing but it is the ratio of output voltage to the input voltage. Here the output voltage is VE, output voltage is collector voltage and input voltage is emitter voltage. Since the common base amplifier cannot operate as a current amplifier, it must therefore have the ability to operate as a voltage amplifier. The voltage gain for the common base amplifier is the ratio of V output to V input. That is the collector voltage to the emitter voltage. In other words, V output is equals to Vc and V input is equals to Ve. As the output voltage is developed across the collector resistance, the output voltage must be therefore be as a function of IC, as from Ohm's law, VRC is equals to IC into RC. So any change in IE will have a corresponding change in IC. Then we can say for a common base amplifier configuration that AV is equals to V output by V input, that is equals to VC by VE, which is approximately equals to IC into RC by IE into RE. As IC by IE is alpha, we can present the amplifier's voltage gain as AV is equals to alpha into RC by RE, that is equals to AI into RC by RE. Therefore, the voltage gain is more or less equal to the ratio of collector resistance to the emitter resistance. However, there is a single PN junction diode within a bipolar junction transistor between the base and emitter terminals, giving rise to what is called the thyristor's dynamic resistance Re dash. Now, for AC input signals, emitter diode junction has an effective small signal resistance Re dash, that is equals to 25 millivolts by IE, where 25 millivolts is the thermal voltage of the PN junction and IE is the emitter current. So as the current flowing through the emitter increases, the emitter resistance will decrease by proportional amount. Some of the input current flows through this internal base to emitter junction resistance to the base, as well as through externally connected emitter resistance. Here for small signal analysis, these two resistances are connected in parallel with each other. Here Re dash, which is in parallel with the RC, where IC is equals to alpha into. Here, since the Re dash value is very small and Re is generally much larger, usually in kilo ohms range, so the magnitude of the amplifier's voltage gain changes dynamically with different levels of emitter current. Here Re is more greater than Re dash. So the true voltage gain of common base amplifier will be AV is equals to alpha by RC by Re dash. That is equals to AI into RC by Re dash. Here, because the current gain is approximately equals to IC which is equals to IE, then the voltage gain equation simplifies to just AV is equals to RC by RE dash. Hence, the analysis procedure is exactly same. The expression of AI, RI, AV, AIS, ABS and Y0 are therefore the same as for CE amplifier, except that H parameter for CB configuration are used. Here we are going to use the H parameters for uh, analyzing the CB amplifier parameters. Here the current gain AI is equals to minus IC by IE, that is equals to minus HFB by 1 plus HOB into RL, and input resistance is equals to RI is equals to VE by IE, because the input parameters are input voltage and input currents are the emitter voltage and emitter current, which is equals to emitter when input resistance is equals to input voltage by input current, that is VE by IE, which is equals to HIB minus HFB into HRB by HOB plus YL, where YL is equals to 1 by RL. Here the voltage gain is equals to AV, that is VC by, VC is the output voltage, VC by VE, that is equals to AI into RL by RI, and output admittance is equals to Y0, that is IC by VC, which is equals to HOB minus HFB into HRB by HIB plus RS. The overall voltage gain is equals to VC by Vs. That is, the output voltage is VC, the input voltage is Vs, input voltage, source voltage. That is equals to AV into RI by RI plus RS, where overall current gain is equals to AIS is equals to IL by IS, which is equals to AI into RS by RI plus RS, where the power gain is equals to PL by PI, which is equals to AV into AI, which is equals to AI2 into RL by RI. So from this, these are used to calculate the current gain in terms of CB H parameters by corresponding CE H parameters. Now let us go with one problem. A transistor CB configuration is driven by a voltage source Vs of internal resistance Rs is equals to 1000 ohms, and the load impedance is a resistor RL is equals to 4 kilo ohms. The H parameters are HIB is equals to 220, HRB is equals to 3 into 10 to the power of minus 4, and HFB is equals to 0 minus 0.98, and HOB is equals to 0.5 microsiemens. For this amplifier, calculate the current gain, input resistance, voltage gain, overall voltage gain, overall current gain, output resistance and power gain. Here AI current gain is equals to minus HFB by 1 plus HOB into RL. Here minus of minus HFB is minus 0.98, minus of minus 0.98 by 1 plus 0.5 into 10 to the power of minus 6 into, that is HOB, into 4000, that is load resistance, which is equals to 0.98, and input impedance Ri is equals to HIB plus HRB into AI into RL, which is equals to 22 plus 3 into 10 to the power of minus 4 into 0.98 into 4000, which is equals to 23.18 ohms. This is the input resistance, where the voltage gain is equals to AV, which is equals to Ri into RL by Ri, that is equals to 0.98 into 4000, where voltage gain AV is equals to Ri into RL by Ri, which is equals to 0.98 into 4000 by 23.18, which is equals to 169. And the overall voltage gain is equals to AV into Ri by Ri plus Rs. That is 169 into 23.18 by 23.18 plus 1000, that is equals to 3.8. And overall current gain AIS is equals to AI into Rs by Ri plus Rs, that is 0.98 into 1000 by 23.18 plus 1000, that is 0.958. And output admittance Y0 is equals to HOB minus HFB into HRB by HIB plus RS, which is equals to 0.5 into 10 to the power of minus 6 minus 0.98 into 3 into 10 to the power of minus 4 by 22 plus 1000, which is equals to 0.78 into 10 to the power of minus 6 Siemens, where Z0 is equals to 1 by Y0, that is 106 by 0.78, which is equals to 1.282 mega ohms. Now the power gain is equals to AV is equals to AV into AI, which is equals to 169 into 0.98, which is equals to 166. These are the parameters which we have calculated by using the common base configuration values. So in this session we have discussed the common base amplifier with the H parameter model of a common base amplifier, and also we have derived the parameters corresponding to H parameters for common base amplifier circuit, and we have done one problem with the H parameter model. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.